Hey guys, this is Mr. C, and in this video we're going to look at a few problems that deal with writing systems of inequalities from real-world contexts, or better known as word problems. So the first one, and we're going to read this, it says Caitlin is selling cookies and cupcakes to help pay for her cheerleading equipment. She needs a total of at least $300. She sells cookies for 50 cents each and cupcakes for $1 each. She has enough materials to make 250 cupcakes and 150 cookies. There's nothing to solve here. All we have to do is we have to write the system of inequalities that we can use to solve a problem from this. So the skill here is just to write the inequalities that we need that represent this whole entire situation. So the first thing I notice is that we have cookies and we have cupcakes going on. And so they both start with C. So I don't want to use variables of C. So when that happens, I generally just use X and Y. However, when I do that, I'm going to have to define those variables. And so I'm going to let X equal the number of cupcakes and I'm going to let Y equal the number of cookies that she can make. All right, so let's write some inequalities. First of all, it says she has enough materials to make 250 cupcakes and 150 cookies. Let's deal with this 150 cookies. So how many cookies can she possibly make? Or actually, you know what, let's go ahead and do, let's see, cupcakes, X, yeah, okay. So yeah, let's go ahead and do cupcakes first. That's X, that's fine. So if X is equal to the number of cupcakes and it says she can make 250 cupcakes, then you would have to have 0 less than or equal to X, right? Less than or equal to, now how many cupcakes can she make? She can make 250. 250. So the X value has to be between 0 and 250. Then for the number of cookies she can make, it says she can make 150 cookies. So for cookies or Y, you can only go from 0, because she can make none, Y all the way up to 150. And believe it or not, on the end of course test, these are items that they do tend to ask, and you just have to write the inequalities down. So far we have 1, 2, and that's it so far. Now, let's look and see what it says for money. She needs a total of at least $300. She sells the cookies for 50 cents each and the cupcakes for $1 each. The cookies are Y and the cupcakes are X. So if I want to write an inequality for that, for the money, $1 for each cupcake, right? Which are the X. So 1.00X plus, she's going to get 50 cents for each cookie, 0.50 cookies are Y. I want all of that money to be at least $300. So to be at least $300, it has to be equal or greater than or equal to 300. So that is the system of inequalities I need for that situation right there. And there are 1, 2, 3 of them that need to be written. All right. Number 2, Roberto can work at most 30 hours per week after school. He would like to save at least $200 this week towards a new motorcycle. His restaurant job pays $8.50 per hour and his lawn care job pays $10 per hour. He can work no more than 20 hours per week at his restaurant job and no more than 20 hours per week at his lawn care job. So there's a mixture of hours going on here that he can work between the two jobs, but there are restrictions. And what we do is we call those constraints. So let's say R equals the number of restaurant hours worked. Restaurant. Okay. So we can use R for that. And let's let L equal the number of lawn care hours worked. Okay, so now we need to get some inequalities here So let's talk about R first, the restaurant hours. It says he can work no more than 20 hours per week at the restaurant job. So our first inequality is going to be 0 less than or equal to R less than or equal to 20. Okay, that's how many hours he can possibly work at the restaurant job, between 0 and 20, or including 0 and 20. All right, our second inequality we need to write is going to deal with the lawn care. So for lawn care, he can work no more than 20 hours a week at the lawn care job. So between 0 less than or equal to L less than or equal to 20 for that one. Now we have some other things going on. He can work at most 30 hours per week after school. So if you add R and L together, whatever that sum is, it has to be at most 30. And so to write that, there's a third one now we have to write. And that can be written as R plus L has to be less than or equal to 30, because that is no more than 30, right? He could do 30, but the sum of these two jobs has to be less than or equal to 30. And now we have some money going on. So the money inequality, and how much does he get from his restaurant? He gets $8.50 per hour from restaurant. So 8.5 or 8.50 times the number of hours he works at the restaurant plus the $10 an hour he gets per hour at the lawn care job. And it says he wants to save at least $200 this week towards a new motorcycle. So all of this money has to be at least $200. So you want it to be greater than or equal to 200. So this problem actually requires you to write 4 inequalities. All 4 of these would be required for this situation right here. And it doesn't even look like it'd be 4 from reading it, but as it turns out, there's 1, 2, 3, 4 of them. That's a great example. Okay, here's our next one. Peyton has $20 to spend at a baseball game. Drinks cost $4 each and hamburgers cost $5 each. He can drink no more than 5 drinks and can eat no more than 4 hamburgers during a game. All right, so let's go ahead and define some variables. So we're going to let D equal the number of drinks that he can drink. And we're going to let H equal the number of hamburgers that he can eat. All right, so let's get some inequalities. Let's talk about first the number of drinks he can drink. He can drink no more than 5 drinks. Well, that means he could drink 0. He could drink 5. But all of the drinks that he can drink are in between 0 and 5. So either 0, 1, 2, 3, 4, or 5. The second inequality is going to deal with the hamburgers. And the hamburgers, he can eat no more than 4 hamburgers. So 0 to 4. And then we're going to put that H in the middle and turn that into an inequality that represents 0 to 4, but no bigger and no less. Obviously, he can't eat negative hamburgers and he can't drink negative drinks. So that's why you had to stop at 0 right here. Then we have another one dealing with the amount of money that he has. And he only has $20 to spend. And so of that $20 to spend, drinks are going to cost $4 each. So $4 per drink plus $5 per $5 per hamburger, 5H has to be less than or equal to 20 this time, because he can't go over $20. He can spend $20, that's why it's the equals part, or he can be under $20 and save some money, and that's why it's less than or equal to. So this one only requires 3 inequalities to satisfy this entire situation, all 3 of them. Very important to define your variables at the very beginning. Most teachers and professors are going to expect you to do that. Even though it may be clear what D and H stand for, they're still going to want you to define your variables. Now the EOC will probably define them for you, so you're not going to have to just pick and choose. They're going to tell you what they want you to use for these 2 items right here. And here's our last one, number 4. This one's a multi-select, so let's take a look. A business needs to purchase new cars and trucks with $200,000 in available funds. Cars cost $20,000 each and trucks cost $40,000 each. It does not want to purchase more than 10 cars or 5 trucks. Let C represent the number of cars and T represent the number of trucks. Check all inequalities that apply. So let's look at this one. This one's telling us that the sum of the cars and the trucks, and that should actually be a T for that. So let me change that to a T. I don't know how that got to be an R, but that's supposed to be a T. So the cars and trucks together had to be less than or equal to 10. Is that true? It says, let's see, it does not want to purchase more than 10 cars or 5 trucks. So the sum of those, I don't see anywhere on here where the sum of the two has to be less than or equal to 10. I just don't see that up there. So I'm not going to check that one. This one, the second one, $20,000 per car. Is that true? Yep, cars are $20,000 plus $40,000 per truck. That's true. Has to be less than or equal to $200,000 because that's the total amount of money that they want to spend. Correct. So this one would be one that I would check. That is a true inequality. This one says the number of cars has to be less than or equal to 10. So do they want to purchase no more than 10 cars? Yep, it says it does not want to purchase more than 10 cars. So this one would be true. As a matter of fact, you could also write that as 0 less than or equal to 10, but that one's also okay because that's what the EOC would probably look like. This one says 10 times the number of cars is less than or equal to 20,000. So what happened here was they see the 10 cars here, so they put a 10 in front of C. They see a $20,000 for the cost of the car. This is kind of meaningless because what this is saying basically, if you divide both sides by 10, is that C is less than or equal to 2,000 if you divide both sides by 10. Nowhere up here does it say anything about C, a car, being less than or equal to 10,000. And by the way, C is standing for the number of cars they want to buy. That would mean the number of cars they want to buy is less than or equal to 2,000. There's no way that that's going to be checked. So definitely not. This one says 40,000 times the number of trucks is greater than or equal to 5. This is actually saying 40,000 trucks. Okay, that's a lot of trucks. So this one, although we see numbers here that are up here, are not in the correct places, and it doesn't make any sense because they're relating money with the number of cars that or trucks that they want to have, and you can't just sit there and relate those two things because they're two totally different things, price and number of cars. This one says the number of trucks has to be less than or equal to 5. That's definitely true because it says they don't want to purchase more than 10 cars or 5 trucks, and that represents less than or equal to 5 trucks. So for this problem, we have 1, 2, 3 inequalities that we would check, and the other ones we would definitely not check. So this is a really good video for a couple problems dealing with writing systems of inequalities. So remember to like my video and subscribe to my channel if you haven't already. I'll see you guys later. Bye.